Welcome to Pointwise's Tutorial Tuesday, where we show you how to use a feature or demonstrate a technique in just a couple of minutes. In this video, we demonstrate how to use the 3 new Vertex-Centered examine metrics that were added with the release of Pointwise version 18.3 Release 2. These metrics will be particularly useful for assessing mesh quality if you are running a Vertex-Centered solver, such as NASA Fun3D or ANSYS CFX, among others. The first new metric is VertexCentered Volume. This is the volume of the dual mesh control volume associated with each vertex in the mesh. The dual mesh is created by subdividing the volume cells into volume sectors, using the cell's vertices, edge midpoints, face centroids, and volume centroid. The volume sectors are then dispersed to each of the vertices in the cell. For example, here we have a hexahedral volume cell, and the volume sector shown in red belongs to the control volume for the lower left vertex. Next, we have the vertex-centered expansion factor. This metric is simply the ratio of the largest and smallest volume sectors in a vertex's control volume. Finally, our last new metric is vertex-centered orthogonality. This metric computes the average of the orthogonality angles associated with each bounding face of the control volume. For instance, the angle computed for the face shown here in blue is the angle between the normalized edge direction vector and the face. This angle will contribute to the vertex-centered orthogonality for both vertices and the edge. Let's take a look at these metrics in Pointwise. Here we have a simple structure block. Let's take a look at the vertex-centered volume. We can see that the probe for the vertex-centered metrics is now showing the extent of the control volume instead of rendering the volume cells. Now let's take a look at the vertex-centered expansion factor. And again, our maximum value is at the interior node with a value of 8, which in this case is the ratio between the contributions from the minimum volume cell here in the upper left corner to the maximum volume cell in the lower right corner. Let's take a look at a more realistic example for vertex-centered orthogonality. Here we have the final mesh for the Wing Power Star-CCM tutorial. So if we select the block and go to Examine Vertex-Centered Orthogonality, we can see that within the TRX portion of this mesh, it is very close to 90 degrees, which is good and what we expect. And then as we get to the isotropic portion, it drops off to around 60 degrees. Also, the shape of the control volume gets significantly more complex in the isotropic region. If you like this video, be sure to hit the thumbs up button or subscribe for more videos like this. If you have any questions or comments, drop us a line down below or connect with us on Twitter, which is linked in the description. Thank you all and have a pleasant Tuesday.